So now we are going into another important new memory management technique called virtual memory management. Okay, virtual memory management. First, understand the word virtual. What do you mean by virtual? Normally, it is referred as imaginary, or in other words, it is not available, but it's look like available. Okay, it seems like available. Actually, it is not available. Or in other words, physically it is not available. Imaginarily it is available, or virtually it is available. Okay, that is what we are going to talk about virtual memory management. Okay, memory is not there, but we assume that there exists some memory. Okay, let us go into detail. Okay, virtual memory is a technique that allows the execution of process that are not completely in memory. This is very important concept. If you understand this, entire virtual memory is over. Okay, once again I'm reading. Virtual memory is a memory management technique and it allows the execution of process execution is allowed. Okay, that are not completely in memory. So now I want to clarify this word. Here we are not mentioning as that are not available in main memory. Okay, we are not mentioning that they are not available in memory. So what does it mean? It is available in memory. That is, process are available in memory, but not completely in memory. Okay, then what does it mean? Partially it is available in the memory. Okay, now you can go and rewind the process of contiguous paging and segmentation. In all the three techniques, your entire process must be available in the main memory. Okay, I think you are able to understand. Entire process P1 size is 100 MB means all the 100 MB must be available in main memory. In contiguous, it must be available in main memory continuously. Okay, all the 100 MB process must be available continuously. That is in contiguous allocation. In paging and segmentation, not necessarily to be continuous, but entire 100 MB must be available in main memory. Okay, in that sense, virtual memory differs from all these three techniques. Now, what we are saying, it is not necessarily to have all the 100 MB. It is enough or it is possible to have only part or only some part of the process in the main memory. Okay, part of the process in main memory. For example, what does it mean? My process size is 100 MB. I'm dividing it into 10 partitions, each having 10 MB. Now in virtual memory, if you have only three blocks, okay, block number 1, 2, 3 in main memory, remaining in secondary memory, even though we can start our process, start our execution. So that I have used the word called execution. We are talking about only execution, not storing. Okay, because storing is not our aim. Okay, we are not just storing our process in the main memory. We are transferring the pages from secondary to main memory only for execution because CPU will take the partitions that are available in main memory only. Okay, so we are just transferring only for execution, not storing. So that execution is possible even though if you have only few partitions in the main memory. Very important first point. Okay. What is the advantage of doing like this? Advantage. Okay. Programs can be larger than physical memory. Okay. So physical memory means what? Main memory. So your main memory size. This is your main memory. Here we are having OS. Okay, so main memory size is 100 MB. Now I can start execute a program of size 200 MB also. Okay, my program size, process P1 size is 200 MB. Actually, in our previous techniques, okay, all three techniques, it is not possible to start P1 because P1 requirement is 200, available main memory size is 100, so it is not able to process. But using virtual memory management, even though it is 200 or 400 or 1000, I am able to start. Because if I'm dividing 200 into 10 partitions, sorry, 20 partitions, each partition will have 10 MB. Okay. So now 100 MB main memory is available. I can store one or two. So partition P1 order, first part, P1 order, second part. Like that, I can store and start execution. Okay, so programs that are larger than the main memory also can be start its execution, whatever may be the size. Okay. Third point, the ability to execute a program that is only partially in memory. Okay, what is another advantage? More programs are in main memory. So like this, P1 is 200 MB, P2 is 300 MB, P4 is 500 MB, P3 is 400, P4 is, for example, 700 MB. So all these programs can be stored in main memory for execution. Okay. So P2, two partitions I will give. P3, two partitions I will give. P4, two partitions I will give. So from each and every program, first two or three partitions may be stored in main memory so that we can start our execution, which is not possible in all our previous three techniques. I hope you understand. Okay. This type of memory management is called the demand page. Okay, so virtual memory. In virtual memory, the actual memory management techniques, what we are discussing is demand paging. Okay, now let us go in detail. What do you mean by demand page? Okay, so to say simply, what is demand paging means load pages only as they are needed. Okay, load pages only as they are needed. Let me give one small example. Listen carefully. So I have one main program. Okay, this is main program. So in this main program, I have one line like this. Okay, if A greater than B, call fact of N. Like this one program I am having. Okay, call fact. So what does it mean? At any time, A value is greater than B value, then I will call one subprogram called the fact. Okay, call one subprogram called fact. Okay. So this main program also available in main memory. Okay, so this is main memory. Here we are having OS. Let me say main memory is process P1, which is a partition. So fact is also a part of process P1, correct? Okay. Now listen carefully. We need this subprogram. For example, segmentation. You take segmentation. Segmentation, now what we will do? Main program one partition and subprogram another partition. Okay. Now listen carefully. When we will call the subprogram fact only if A is greater than B. Assume throughout your program A is not greater than B, then fact will never be called. Correct? Okay, so assume throughout your program A is not at all greater than B means what? The fact subprogram will never be called. So it is a waste to have that fact subprogram in main memory for execution because that is not going to be executed at all. Okay, as long as A is not greater. Okay, able to understand? Okay. So now you can ask one question, sir. You are saying A is not greater than B, then it is okay. Suppose A is greater than B, what will happen? At that time, definitely it must be available in main memory. Okay, so now I am changing my sentence. What sentence? Load a program from secondary storage to main storage only. It is when only if it is required or whenever it is required. Okay, so what my logic is, first I will store the main program in main memory. Okay, I will store main program in main memory. First line I will execute, second line execute, third line I will execute. Fourth line, let me do this. Fourth line, this is A is greater than B. When I am executing fourth line, If the condition is true, at that time only I will load the subprogram in the main memory. Only if it is true, at that time only I will load the subprogram from secondary to main memory. Suppose if this condition is false, no need to store it in main memory or no need to have it in main memory. Able to understand? Okay, like this segment may have 10 different partitions. All the partitions will be stored only if it is required. So now you see this load pages. Page means what? Partition of your user program. Okay. Let it be equal partition. Let it be variable size partition. Let it be segmentation partition. Whatever may be the partition. Okay. Only load the pages only as they are needed or whenever required. At that time only you are going to load the program into main memory. Okay. Now you assume, now I ask you one question. Suppose your program process P1. Okay, process P1 is having, for example, 20 segments. Okay, process P1 is having 20 segments. Now my question is, how many segments must be available in main memory to start execution? Okay, how many segments must be available or minimum? Okay, how many segments that must be available in the main memory?